Good afternoon, everyone. I'm Nitish Uplavikar. I'm a researcher at Comcast, and today I will be presenting about our open source contribution and how it can help with scaling up privacy threat modeling. This was part of work done over 1 or 2 years ago, and these are my colleagues who have worked with them. So starting up, I'll quickly go over the introduction and quickly go over the background. I'll dive deep into our contributions, which consists of 12 privacy rules. Then I'll walk through an example and then conclude. Okay, so I think everyone here knows about privacy threat modeling. It is basically a privacy engineering process wherein systematically you evaluate a system for any privacy threats. You analyze and provide mitigation education to the teams that are undergoing privacy threat modeling session. And usually as part of this particular sessions, the privacy engineers would model the system, try to build the data flow diagrams, identify the different technical and data assets that are part of the system, as well as how the data flows within the system. Next, they would identify the threats for this particular, they would basically identify the threats for that particular system using some privacy threat modeling framework. And finally, they'll manage the threats by providing any remediation strategies or providing some additional education around it. Most of the privacy threat modeling sessions are manual in nature. However, there could be some pain points there in the sense that these sessions could be resource intensive in the sense that you require a lot of data or the entire data picture of the application that is currently undergoing threat modeling. And then you also need to schedule all the stakeholders who need to be there on the call. Next, this is a cognitively demanding process in the sense that the engineers would need to identify all the different interaction points between the data and the assets, and then run it against the privacy threat framework, identify the applicable threats, then find out what is the risk for each particular threat, how likely it is, and how big the impact could be. And finally, they would also need to educate around remediation. To help with or to assist with privacy threat modeling, we have come up, we have a solution called Privitect. We have already open sourced it. As you can see the QR code there. Here, the input would be a YAML file, which would be a representation of the application. It would pass through a rule engine, which has around 12 privacy-based rule sets. These are derived from LINDDUN. And eventually, you'll see the potential privacy issues or threats that could be applicable to the system. So who does this apply to, or who can use this? So privacy engineers can use this in order to offload some of the cognitively huge tasks. They can offload the threat identification part and focus more on the education aspect, what privacy enhancing techniques could be used, or what are the mitigations that could be used there. Moreover, developers can also use this as a self-evaluation tool. They could proactively, before a privacy threat modeling session, try and identify some of the privacy threats that could be applicable. It could also be used in the ideation phase, wherein basically you can find out what could be potential consequences or threats of any design decision. Okay, then our particular Privitect is based on Threagile. The reason we are using Threagile here is because It allows one to, Threagile, first of all, is you might know it's an open source security toolkit that you can use to determine the security threats for a given application. And the reason we are using it because it allows one to declare the architecture of their system as a YAML file. It already has a rule engine which consists of almost like 50 security-based rules. And it has features like reporting. For example, it can generate threat reports. It can also generate data flow diagrams. And it also provides some mitigations for those particular applicable threats. Threagile is can be deployed in a flexible sort of way. You could have it running as a server, run your architectures based on it, and you can also run it through command line just as a command. So here is basically like a simplistic view of how Threagile operates. What would usually happen is like the application architecture would be provided as an input here. It gets parsed, and then the rule engine comes into the picture where the evaluator would try and run the rule set against the architecture and generate a bunch of threats that can be viewed by the privacy engineers or the developers who are using this particular tool. Then coming to LINDDUN, I think most of us are familiar with LINDDUN. LINDDUN is a privacy threat modeling framework, and the reason we are using it because it covers a comprehensive taxonomy of privacy threats. It's a practical method to evaluate an application, like a real-world application. It aligns well with privacy by design concepts, and it does include mitigation strategies, including like privacy enhancement technologies. Like it has some recommendations for that, and it's widely adopted and recognized by authorities. Now, let us see how we go from framework to code and how Privitect was built. Initially, we compile all the LINDDUN threat definitions and trees. These contains all the details about each threat and with examples, and they are broken down into multiple sub-threats. Then we try and map this particular then what we do is we map the LINDDUN threats with a real-world incident database. For example, here we use the Various database, which has around like 209 real-world privacy incidents. We do this mapping using the LLMs. Then we identify out of those LINDDUN threats which LINDDUN threats can actually be coded or automated. We find that around 61% of LINDDUN threats are codable. And considering the mapping with the real-world incident, we find that 76% of real-world incidents can be covered by these 61% of codable LINDDUN threats. Finally, we filter the rules or the threats. We use a greedy strategy here and select 12 rules. Out of these 60, we find that if we select the 12 rules and optimize for reducing the amount of burden that is put on the user to as part of adding new inputs for these rules, we find that these particular 12 rules can cover up to 67% of real-world incidents, and 53% of LINDDUN threat categories or the threats can be covered by this particular 12 rules. In the end, we go ahead and basically implement it and test on some sample applications. Here is just the content that I mentioned, that Privitect can cover, like if you just consider codable LINDDUN threats, Privitect can cover 87% of those threats. And then if you were to use these 12 Privitect rules, close to 67% of real-world incidents would be covered. However, in order to implement this solution or these rules, we had a few challenges. One is, how do we go from LINDDUN threat definitions to code? How do we address this gap? So some of the, the way we approached it is we scoped down the LINDDUN threats based on the context and the organization details. So that was one. And the other thing was we did multiple rounds of reviews with subject matter experts within the organization and try to convert these particular threats to the code. The second challenge here was Threagile is built for security, detecting security risks, and it's not exactly, it won't detect privacy issues out of box. So we had to do some augmentation here. We had to augment Threagile structures with additional attributes for the assets, etc., so that privacy context can be added within the architecture itself. Here is a list of 12 rules that we have contributed. 2 of them are OWASP-based, but rest of them are LINDDUN-based. And you can see, if you want to see what exactly a LINDDUN threat category or threat it detects, those we have provided it in the brackets. The DD 1.1 would be data disclosure, and then that would be, DD 1.1 would be the ID within it. So I won't go into detail for all the 12 rules today. But I want to walk through a sample example on how did we go with building. We take a threat and see how we built a rule for it. So this particular threat belongs to data disclosure category of LINDDUN. It's called data disclosure by unnecessary propagation. Here the definition or given within LINDDUN would be something like data is accessible by or propagated to other services where it is not needed. So here we had to scope what are other services. Is it like external services, internal services? So here we assumed it to be external services. Then we came up with the high-level logic just to identify whether this particular rule is this codable or not. So that developing that helped us. And finally, we implemented the logic. I won't go into the coding details, but the rightmost column is what it would look like if you extend Threagile for this particular rule. And in order to add a rule within Threagile, typically you need to add 3 functions here. One would be the actual rule description. In this particular case, what you will need to add is what does this rule detect, and then what are the mitigation steps that are possible. The second function you would need to write is the rule logic. This again, I won't go into the details. This is just an idea about if you were to extend this, you just need to add 3 functions: the description, the logic, and the third one is basically talking about the impact and likelihood of this particular threat happening. So if you add these details within this function, within the report, you can sort it based on the threat severity. So here I have a working example. I'm not sure if everyone is able to see, but here we have, I just took a short example wherein you have 2 assets, app server and browser. Yeah, here we have the app server and browser, and this is a communication link going from app server to the browser, and we have around 6 data assets that are being sent. For example, one is a car make, date of birth, citizenship, disability info, employee location, ethnic origin, and biofingerprint. So these are being sent to a browser. Now this, the browser information is given in the right-hand side YAML representation. Here you can see that it is processing citizenship, it is storing employee location, and then it is trying to send back the date of birth to the app server. So the way this rule would work is basically for the browser, it would look at what are the data assets that are coming to the browser, and then it will look at what are the data assets that are being processed or stored by this particular browser asset. And then whatever extra data assets that are being received which are not being used, this rule will highlight it, saying that there is a privacy threat due to this particular like data assets not being used. So for example, here you can see date of birth is being used. Citizenship is also being used in some way. Right? Likewise, employee location is also being used. So there are a few assets which are not being used, as you can see. Then we run this particular, run the Privitect rules over this architecture. And here you can see there are 2 threats that are being generated, one for disability info and ethnic origin, which were not being used. So this was the main content of my presentation. And I would like to conclude by saying that Privitect can help with offloading some cognitive load within threat identification. So it can help with scaling up privacy threat modeling. Basically, it can also be used as a self-service tool by the developers, as well as a documentation tool. Privitect is extendable, and we are open for additional contributions. And this, here we also saw that privacy threat, threat frameworks cannot be fully automated. Just a % of them can be. But we saw that almost half or more than half can be automated. And finally, if we apply scoping strategies based on, let's say, your organization, you can cover substantial real-world incidents. You can basically cover or detect such kind of issues. So that's all from me. Thank you.